Hello there, and welcome to the AWS for the Retail Industry webinar. My name is Ryan Shuttleworth, and I'm a technical evangelist at AWS. And today I'll be taking you through the AWS platform, some concepts behind it, and I'll be joined at the back end of this webinar by Adam Bidwell, eCommerce manager at Geiger, who will take you through their use of AWS and their journey through AWS into the cloud. The agenda today, just to give you some framework to work to, is that I will talk around Amazon Web Services, give you some background of where it comes from in the Amazon family, introduce the concepts of utility computing and elasticity, and then we'll dive into AWS and the retail industry. So starting with some basic information about security and compliance, talking about three then broad areas of use of AWS, namely highly available customer-facing systems, running your core platforms and back-office platforms within AWS, and then performing customer analytics, doing large-scale customer weblog tracking and so on within AWS. And then we'll jump into Kurt Geiger's customer story at the end to finish off. So by way of background, Amazon Web Services is part of the Amazon.com family. So there are three parts to Amazon. Firstly, it's consumer business that I'm sure we're all familiar with, and we've all bought presents, books, CDs for friends and family. Amazon.com also has a seller business where third parties can use the e-commerce infrastructure of Amazon for us to stock their goods or ship their goods or simply manage payment for those goods. And then the third part is Amazon Web Services, our IT infrastructure business. Amazon Web Services is a distinct business in its own right and a strategic business as part of Amazon. I often get asked the question, how did Amazon move from distribution centers and packing boxes on the left to cloud computing and, if you like, unpacking server boxes and putting them back on racks? The story started about 10 years ago with the enablement of that seller line on the Amazon e-commerce infrastructure. As we started to open up our Amazon retail technology platform to third parties, our internal IT teams became more service orientated and had to learn to get very smart and efficient on how they deployed highly scalable technical services for use by our internal business units and also those third-party sellers on the outside world. One of the first services that we published was a catalog search. And it was a very basic web service that enabled third parties to search the Amazon.com catalog and embed those results in their own websites. And those early forays proved that developers in particular were hungry for more of these services from which they could innovate and mash up content into existing platforms. On the back of that success, AWS was born, and its mission is simple, is to enable businesses and developers to use web services to build sophisticated, scalable applications. And it's useful to note that web services, in our name, is what now people call the cloud. As I said, AWS is a strategic part of the Amazon.com family, and the testament to this is the number of customers that we have on the platform today. We have hundreds of thousands of customers, from small startups to major global brands, some of them shown here from Samsung, Shell, Nasdaq, Sega, and so on. It's interesting also to note that Amazon.com is a customer of AWS. So a large part of the Amazon retail infrastructure runs on AWS, and they are a customer just like any other customer. The scale at which AWS operates is significant. This is a statistic that each day Amazon Web Services adds the equivalent server capacity that would power Amazon.com when it was a global $2.7 billion enterprise. Each day, that amount of compute, storage, networking capacity is provisioned in the AWS cloud on a global basis. Another statistic of the scale that we operate at. Objects in S3, our simple storage solution, have recently surpassed 1 trillion. An object being a technical asset of 1 byte to 5 terabytes in size. And S3 is a platform that stores these objects at 11 nines of durability. At peak transactions, we handle 750,000 transactions per second reading and writing these objects, whether they be powering backup and archive solutions, whether they be powering static content on websites or product catalogs. The type of content is very varied. And in objects in S3 at this level, this gives you an idea of the scale at which we operate all of our services and the principles that we apply to ensure they're always highly available, highly scalable, and highly reliable for you to use. So what are those principles? The first is utility computing, and this is what AWS is all about. So just as you would use electricity and you would plug a device into the socket and expect the electricity to be available on demand when you turn the switch on, that you expect to pay as you go for the electricity you consume, and you expect the consume to be highly available, always there, and to be uniform, consistent, whatever socket you plug into. Utility computing brings those concepts to data center infrastructure. So everything that happens inside a data center, we make available on demand, pay as you go, in a highly uniform and consistent way across the globe, and highly available. Amazon has wrapped that infrastructure in a consistent application programming interface or web service interface, such that all the things that happen inside a data center, such as compute, networking, databases, workflow, messaging, load balancing, and so on, are available on an on-demand, pay-as-you-go, highly available and uniform basis. And just as you wouldn't plug into a single electricity station when you're powering your electrical devices, Amazon operates its data centers on a global footprint. We operate a number of regions across the globe, and regions are areas in which you can choose to run your compute or store your data and that have legal jurisdiction restrictions. When you choose to run your data in EU West, for example, we will not move your data unless you choose to do so. And within those regions, we operate availability zones. Availability zones are physically distinct data centers that enable customers to deploy highly available applications within a region. And customers are global, and we operate a number of edge locations for distributing content or managing DNS records. This gives us the fastest possible response time to customers and users wherever they are on the globe. So utility computing brings us to a fundamental concept of elasticity. Elastic capacity is all about trying to meet your IT demands or the capacity requirements being placed upon your servers and infrastructure with the right amount of infrastructure being provisioned to support it. Now, in a traditional world, traditional IT capacity is shown here by the red line on this chart. So a certain amount of machines, of networking, of database, of storage that needs to be provisioned to handle the peaks in your IT needs, shown in blue. Capacity planning is a science at best, and there are various different ways in which people experience IT demand hitting them, from simple on-off, shown at the top left, where we might have batch processes or significant events which cause a demand to be placed upon our infrastructure. Fast growth, where we have maybe an internet presence which is taking off, and social media means that we have to provision chunks of resources, shown there in the red step, to handle the growth in demand on a service. Variable peaks at the bottom left, where best guess applies. We simply don't know how much demand is going to be placed on us at any point in time. And predictable peaks, such as people with mobile applications, where they experience users logging in the morning and in the evening on their commute to and from work. In all of these styles of capacity curves, the typical scenario is wasted resource, shown here in red, where we have to provision a certain amount of IT resources over the blue line in order to handle the demand that hits us. And in the worst possible case, shown in green, where we haven't provisioned enough, customer dissatisfaction results, whether that be lost customers, lost revenue, whatever measure we place on it. So elastic capacity is the idea that we can provision the right amount of resources balanced to the requirements any particular time that is placed on any given IT system. So whether we'll be talking about batch processing, where we turn on elastic capacity when required, whether we have a fast growth service where we're tracking closely the demand placed upon the application, variable peaks and predictable peaks, and so on. Balancing the amount of resource you apply and therefore not paying for the resources when it's not required is a fundamental concept of AWS. And it's all about trying to avoid stuff like this. The last thing we want is, during unpredictable seasonality maybe of a service when we have excessive user demand, is users to receive this sort of message. With AWS and elastic capacity, you can avoid users being timed out or servers being temporarily unavailable or unable to service your requests. AWS allows you to scale from one instance, one compute resource to handle this sort of demand, to many thousands and back again. And when you're not handling thousands of resources, you're simply not paying for them. It's an on-demand resource pool. An example of this in action is a company called Animoto. Animoto had a simple web application that enabled you to upload some photographs to a website and upload an MP3. The service would then take those photographs and mix them in time with the music and produce a movie that they would then send back to you. They ran at a steady state of 40 instances within EC2, and then they launched a Facebook modification whereby you could point the service at a Facebook album and it would do the same task with an MP3, but afterwards it would email or notify those people tagged inside your photographs to say, hey, there's a movie of you, would you like to come and see it? Would you like to do one yourself? And they scaled from 40 servers to 5,000 in 3 days by leveraging the properties of AWS and auto-scaling and elastic capacity, and they sat back and they watched that happen without having to lift a finger. And when that demand subsided, they scaled back automatically and stopped paying for the resources required to handle that demand. A lot of people then ask us about the data that they place within AWS. Now, AWS provides a platform that you can rely upon and a number of security credentials that come with it that I'll explain now. Amazon operate a shared responsibility model. That is, the foundation services of compute, storage, database, networking, the regions that we operate our facilities within, and the edge locations where we serve our content from, are covered by Amazon's responsibility. And our responsibilities are to certify those areas of the technical platform to various levels. So we're Sarbanes-Oxley, SOX compliant, ISO 27001 certified, PCI DSS level 1 compliant, and we're SAS 70, now known as SOC 1, Type 2 audited. So our infrastructure on a global basis meets some very high, strict audit requirements, and they're audited on a 6-monthly basis. The things that you run on top of Amazon are your responsibility. So whether you choose to run your data encrypted on top of AWS or not, or the types of applications that you deploy and how you secure those on top of AWS infrastructure is your responsibility. So whilst we take care of ensuring that the foundation services meet the highest possible certification and standards, and the controls that AWS operates at in terms of change control, management of those resources are publicly available and inspectable, it's your responsibility to ensure that your applications and your data are secure on top of that. So much in the same way as you might use a co-location facility or a managed service provider that provides you with foundation services to a certain given standard, it is your responsibility in that environment to manage your security of your own application and data. Exactly the same applies within AWS. So this gives you a basis of enterprise level quality of security management that you can trust and you can rely upon to run your applications within. And this is testament to the number of customers that we have and the global brands that we have operating within AWS. So that's the introduction over with, and what I wanted to do now was to dive into 3 broad areas of AWS usage within the retail industry. And the first one of those is, if you like, the obvious, customer-facing infrastructure. I'm going to take you through some technical rules about how you can deploy web applications or marketing presence within AWS and ensure that they meet the highest possible demand based on them during seasonal peaks, ensure that your customers are always getting a fast response. And a simple set of rules that we can talk you through that will give you some context to how you can deploy your applications within AWS. So rule 1 is service all web requests, and make sure your requests get to your front door. What do I mean by that? So when a request comes in over the internet, the first thing it does is hit a DNS server, and that DNS server will point to an application, your website, for example. If your customers can't resolve you via DNS, there is no point doing anything to your application and data to make sure it's scalable or available. They simply won't get there. So if your clients can't resolve you, then any sort of technical activity on application and data is irrelevant. First service that we apply within AWS is something called Route 53. And the takeaway here is that Route 53 is a 100% available DNS service. So we will provide a guarantee that we will respond to all requests for DNS entries that are made to us. And it's operated globally, it's highly scalable, and enables you to do complex features like latency-based routing, which I'll come to in a second. So if you want to ensure that when your customers hit your URL in a web browser, that they actually get to you, Route 53 is a perfect partner for that sort of business. Second part of this rule is to make sure you open the door when customers arrive. So if they found you via a DNS server, they need to make sure that your application is up and running. There's a number of constructs within AWS that enable you to do that and to do that reliably. The first is elastic load balancing, which is a virtualized load balancer that enables you to spread load across availability zones and computer instances running in each of those availability zones. So shown here, I have two regions within which I have load balancers load balancing across two availability zones, and within each availability zone I have a pair of applications. This ensures that your application is highly available, and in the event of any particular regional problem or technical issue of your applications, you have sufficient resource and automatic balancing of requests across those resources to meet the customer demand. And the third rule is you need some data to drive an application typically. So have data to form a response. And within Amazon Web Services, we have managed databases called Relational Database Service. So you can deploy a highly available master-slave MySQL server, Oracle server, or MS SQL database server that's fully managed by Amazon, and it will be deployed in the same constructs of availability zones and regions. So you can always ensure that your applications have a database layer to talk to form a response. Now this construct is a basic pattern within AWS, the use of regions, availability zones, to use of load balancing and Route 53. And later when we look at some of the customer case stories, we'll draw this into sharp relief again as we discuss how they've deployed against this pattern. So rule 2, now that you've got an application deployed in the cloud and your customers can find you, is to service requests as fast as possible. There are many different statistics out there today that will talk about the longer somebody has to wait for a response on a website, the less chance you have of keeping them hanging around as a customer. So getting to your application and your data as quickly as possible to form a response is key. And the first rule is choosing the fastest route. With AWS, you can deploy applications on a global footprint. So whether you're servicing local customers in Asia Pac from our Singapore region, customers in America from a US region, or Europe from a European region, Route 53 gives you a mechanism by which to detect where that customer is coming from, measuring the latency for that customer to a particular region, and to return a DNS record for the closest region. This enables you to get a customer the fastest possible response time to your applications when you deploy them on a global basis. Second thing you can do is offload your application servers. Integrated within AWS, we have a service called CloudFront, which is a content distribution network. This enables you to push things like static content from your web applications to our edge locations, which I mentioned previously, and have them served locally to the users for the fastest possible response time. This has the benefit of reducing the load on your application servers, but also improves the page load time to your users, things like product images and so on. Perfect to be served from an edge location. To show that in action, without CloudFront, you can have a number of instances running against the database, and you have a particular capacity that you've had to deploy against. In this case, I've got 6 instances running to handle my user load. When you deploy with CloudFront, you can offload that content requirement onto CloudFront, and as a result, your application servers do less work, and you can reduce the number, here shown halved to 3. Effect that has on your users is that the response time goes down in each case. And the server load also goes down in conjunction. So shown there on the far right of the chart, the fastest possible response time for a user is using a CDN such as CloudFront for managing your static and dynamic content. Rule 3 then is to then handle requests as they come at any scale. So our customers are founders. We've responded as fast as we can. Now we have many thousands or hundreds of thousands of requests hitting us per second. The first thing we can do is scale up within AWS. So scaling up means choosing a compute unit or instance size that meets a particular task. We have over 14 different instance types available, from micro through to cluster compute. And broadly speaking, for each doubling of compute capacity you apply, you double the price you pay per hour. So starting from 2 cents an hour, we can move up to very high CPU or very high memory instances that give you the ability to scale the application servers that run your websites. Second thing you can do in AWS is leverage elasticity and scale out. You can leverage a concept called auto-scaling, where auto-scaling allows an automatic triggering of the number of resources being deployed behind an application to scale up or down based upon a particular set of triggers or properties. So shown here, I have an auto-scaling group, minimum size 4, set with a maximum size 200. And based upon a trigger, such as average CPU load across this group of servers, or latency seen from a web request in terms of the application responding, I can set some thresholds on that value, and then auto-scaling will automatically add servers to the pool to handle the increase in demand that may be hitting me. And auto-scaling will automatically shrink back the resources as that capacity demand subsides. So the Alamoto example used exactly this construct to scale from 40 to 3,000 servers and back again to meet their peak in demand. Auto-scaling can be done various different ways. So you can auto-scale manually. You can trigger it via an API or a simple command line to launch or terminate instances. You can do it by schedule, so a particular time of the day, week, month, year. By policy, so in response to changing conditions, so dynamic data driving the amount of resources that are deployed. And also on something called an auto rebalance, so that if there are problems in an availability zone, for example, we'll ensure that we automatically keep the right pool of resources available to service your demand. So examples of that might be preemptively scaling your cluster of servers before a marketing event to add 10 more servers. By schedule, so scaling from 0 to 2 to process some messages in a queue every Friday night, or to double the capacity on a Friday night because that's when your weekly peak hits you. To dynamically scale based upon average CPU load or latency seen from a load balancer. And then, as I mentioned previously, auto-balancing in the event of some sort of failure of a particular instance or application in the availability zone. Another thing you can do to handle requests at any scale is to do a dial it up, as we call it. So there are a number of things within AWS that enable extremely high performance or high throughput applications to run. So if you are looking at NoSQL databases, you can use a service called DynamoDB, where you request a provisioned capacity for your data tables. Maybe you have a requirement for 10,000 read writes per second on a database table. You can simply request that amount and pay for that amount on a pay-as-you-go basis. Likewise, if you've got some proprietary databases, you might have particular IOP requirements on your disk drives. Elastic Block Store is the volume equivalent within AWS. You can request provisioned IOPS backed off onto SSDs that enable you to get consistency on the read-write performance. Then Rule 4 is simplify your architecture with services. So there's a number of things within AWS where we wrap software in a service and manage it for you to reduce the burden of operating applications and IT infrastructure in the cloud. And the first of those is relational database service. So database as a service, as I mentioned before, MySQL, Oracle, or Microsoft SQL Server, you simply request the scale of database that you want, how available you want it, the backup regime to be taken on that database, and we'll provision that resource for you and give you an endpoint to talk to. So this takes away all the undifferentiated heavy lifting of managing a database, of managing the backups, of managing the scaling, dealing with sharding of tables and so on. And likewise, if you're running something like Cassandra, the equivalent in AWS is something called DynamoDB. So where you might have very high throughput data tables, key value pairs in a NoSQL database, you can use DynamoDB, and we'll take care of all the management of a cluster of resources to handle that application load. There's a number of other services that we have which take away the grunt work of common architectural elements of an IT system. If you're running queuing for asynchronous delivery of messages between application components, you can use Amazon SQS, where your messages are held highly reliably and made available on a regional basis. In the same way as S3's highly durable storage, your events can then be managed within SQS at a very low price point. Or if you're dealing with workflows across applications, such as customer sign-up processes or customer order processes, Simple Workflow gives you a similarly reliable and highly available framework for handling that process state, handling the metadata you might need to carry between systems or groups of servers to process a particular business task. Amazon.com has a search engine, and we've made that same search engine technology, Amazon A9, available as a service. So if you have deep catalogs of information, you might have reams of information like customer reviews, you can make those available through Cloud Search, where you simply push documents into an endpoint and be given an endpoint for search. And we will automatically scale that search engine to give you consistent high-performance response times for your customers when they're searching on your websites. Then lastly, we have Elastic MapReduce. Elastic MapReduce is a managed Hadoop cluster. So if you're doing very high volume weblog analysis or customer activity analysis, and you're managing Hadoop clusters to process that in a timely fashion, Elastic MapReduce is a Hadoop as a service. So you simply pay for the time that you're using a Hadoop cluster. There are other services, such as email services and so on. The list goes on, so do take a look at the website to find out more about them. I mentioned one of the services there called Cloud Search, and there's a great example of Cloud Search called SmugMug, who are a photo sharing application. Their CEO talks about saving many months of re-engineering and development time, not to mention the operations savings they had of not managing a search cluster, by using Cloud Search or using an Amazon Web Service software as a service where they don't have to deal with the gritty work of managing that themselves. SmugMugs have a search box, and then down the left, to show you some of the complexity behind that search engine, lots of different product faceting in this case. So metadata around photographs such as aperture, the date taken, and so on. So you can use Cloud Search to create equivalent searches on products that Amazon.com has in its retail sites for your own sites with ease and in a few minutes. Another example bringing some of these technical rules together is RangeSpan. So RangeSpan had about 10 million product records in about 44 gigabyte collection. And on their infrastructure, they were hitting about 2,000 transactions a second. As shown on the right is their application architecture. So they have elastic load balancers, as I've shown in that pattern previously, distributing load over web servers and app servers in multiple availability zones. And they were running our Amazon RDS as their data tier, but also running MongoDB on their own managed instances. Some of the services that are used on the outside are shown also. Elastic MapReduce for customer analysis, SQS for decoupling applications with queues. They were using our simple email service to send out customer emails, and then Amazon CloudWatch as a unified framework for monitoring everything that was going on inside their infrastructure. The need for this, and their words, were to handle substantial increases in capacity that hit them during particular holiday seasons. Simple demand increases, unpredictable spikes in demand, and they were able to scale up and out automatically using AWS. So a second core use case that we see retail organizations using AWS for is running their core back office platforms. Now, there are many different back office platforms, but one I wanted to draw your attention to is the fact that AWS is certified to run a range of SAP applications. So if you have SAP in your business or branch offices, AWS has a range of certifications for running those on different database platforms. So AWS is not just for running web apps. So some of the customers will be running SAP for non-production systems, so they'll have dev, test, staging environments, saving them a lot of time, effort and cost on running those environments on their own tin. They're doing backup and archive into AWS, so taking database copies such as Oracle databases into S3 to reduce their overall cost of backup and storage, and running production systems such as analytics or branch offices. You can also use the Amazon Marketplace to grab shrink-wrapped configurations for popular application types. So shown here, for example, is Magento. So if you're running a Magento e-commerce platform, you can launch from the Marketplace a Magento instance, and in this case shown the pricing for an EU West region for running that instance. So some application vendors publish into the Marketplace, and then the licenses for those applications are included on the hourly rate. And a very core service to running back office platforms is relational database service that I've mentioned a couple of times. So if you have, for example, Oracle applications, you can start an RDS instance and bring your Oracle license to AWS, such as using Enterprise Edition for Oracle database, or you can use the Oracle embedded license within instances. We've got support MySQL and SQL Server where the licenses include, but the benefit here is that you can take away the management of things like backups, patching, failover and replication of data, because we take all of that pain away from you and manage it for you as part of the ongoing hourly price. Another use case that we see commonly is around disaster recovery in AWS. So where you already have some maybe on-premise physical infrastructure, you're looking to de-risk that management by producing a DR failover site and treating the cloud as a second data center. And a common pattern is one called a pilot-light architecture, where using something like RDS, you create a core replication of your database in the cloud and keep that synchronized. And you build your AWS resources around that data set and leave it in a stopped state so you're not paying for it. And then at some point you might need to trigger the use of those resources, and then you can turn that pool on as events dictate, and you can match the current production capacity in the cloud using things like auto-scaling, so effectively move your traffic onto the second virtual data center. So switch over to systems in AWS. And it's a common way for people to take a stepping stone into the cloud and a non-production use case. Third is customer analytics. So no presentation today would be complete without the concept of big data. And big data means that we can collect more information today because there is more data there to collect, and data has a certain gravity. So I want to take you through these concepts and introduce the concept of elastic map reduce and show you what some customers are doing with it. So data at volume has a certain inertia. So as we collect more data, maybe it is click analytics of what people are doing on our websites. Maybe it's social information relating to the use of our products in the outside world or our customers. As we collect the data, it becomes quite voluminous. And it makes sense then to move the applications that you are using that data close to that data, whether it be for a throughput performance or latency reasons. There's a number of reasons why you'd want to do that. And the idea of bringing compute to the data in a sort of transient throwaway way is perfect marriage for Amazon Elastic Compute Cloud EC2. So where you have a very large data set and you want to process it in some way, ask some questions of it, perform some analytics, get the results, and then the compute that you use to do that is entirely disposable. AWS allows you to bring that resource to the data. So cloud has the power to process your information from one instance, as we saw before, to many thousands and back again. So So the revolution around something called big data is the fact that we have lots of it today. Whether it be simply application server logs, that we have reams of gigabytes of data about what our customers are doing, we have it and we can store it and we can analyze it, and we can do that economically and we can do it fast. So to put that into context, some of the questions you might want to ask is who your customer really is, what do people really do with your products, what is happening socially, and how do people really use them in the outside world. Gathering this sort of feedback, whether it be from your internal systems or via external information sources, is something that Amazon does on a regular basis. So before this webinar, I decided to log into my amazon.co.uk account and was presented with a homepage that gave me some product recommendations. Now, I did take a step back at this because Moroccan oil treatment is not something I regularly use or buy. So I had to dig around, and I looked in my inbox and I looked at an email that was sent to me that showed me my basket which had shampoo in it that hadn't been bought, and saying, would you like to buy it? Now, at this point, I did ask my girlfriend if she'd done anything. She said, yes, I'd forgotten I had that in the basket, and she bought it. There's a couple of lessons. Don't leave your Amazon account logged in at home, because it will get abused. But lesson 2, the real one here, is to use the data you have to drive proactive processes. Now, it's something that Amazon Retail do all the time. So they'd looked at my outstanding basket, they'd looked at the activity I'd done on the website, they'd personalised my experience and then driven proactive marketing, which in this case resulted in the purchase of shampoo. Now there's an equation behind some of this. So 1 instance for 100 hours equals 100 instances for 1 hour. Within AWS, that costs the same. And in a small instance, that will cost you $8. So 100 computer units for 1 hour will cost you $8 of a small instance types. And this thing that I mentioned before, called Hadoop, enables, wrapped up as Amazon Elastic MapReduce, enables you to effectively split up jobs and to scale out the processing of very large data sets to give you some sort of answer in a much shorter time than would be available if you used 1 instance for 100 hours. You can do 100 instances for 1 hour. So what is it? It's a framework that splits your data into pieces, lets some processing occur, and then gathers results. So somewhere you can drop your code into the Elastic MapReduce. Maybe the question you're asking, your technical teams can codify it, and we will deploy that on an Elastic cluster with the properties you define, such as maximum 100 nodes. We'll run that and deposit results into things like S3. So you might have a very large click log on your website. Lots of actions, for example, by John Smith, are included in that log. Elastic MapReduce will split that log into many small pieces, allow the processing to occur within an EMR cluster, and then aggregate the results from all those nodes, and then answer the question, what John Smith did. And the EMR lets you do that in a fraction of the time, because you can throw as many resources as you so wish as the EMR cluster to reduce the time it takes to come to that answer, whatever answer you may be looking for in your data. So 1 instance for 100 hours equals 100 instances for 1 hour, $8. But just as easily, you might have 1,000 hours for 1 instance. It's the same as running 1,000 instances for 1 hour, and that will cost you $80. So a case study around this is Yelp. So Yelp pre-processed their application server logs to produce a number of files which sit behind their web application. And they're producing these files around 200 times a day using Elastic MapReduce jobs. So pre-generating things like people who viewed this also viewed that, taking review highlights that are being generated on their application, generating autocomplete lists for searching, correcting or producing commonly misspelled items, and so that they're able to better guide a user on their searches, and doing ads and placements. And with AWS, their search and data mining manager talks about their developers doing things they couldn't do before and allowing their team to focus their energies on their business challenges, not the technical challenges with managing things like Hadoop clusters. And another common brand which uses Elastic MapReduce is Etsy. And they do exactly the example I've described, which is taking their weblog, analyzing what customers are doing, what journeys they're taking, what they're looking at, and what they're not, and then fine-tuning the indexes that are produced behind their recommendation engines and algorithms. So with that, I'm going to introduce you to Adam Bidwell. So Adam's the e-commerce manager at Geiger, and Adam's going to talk you through his journey into the cloud, the things that he uses AWS for, and why he's gone this way. So thank you, Adam.
Thank you, Ryan. Good morning, everybody. Ryan's just asked me to say a few words about our experience at Geiger to you this morning. My position here is that I'm the development manager at Geiger. I've been here just over 2.5 years. We've grown the site from a simple site that was hosted by an agency through to one that we now manage the infrastructure ourselves. And during that time we've adopted AWS. So to just give you an idea of the sites that we're managing, we've got 3 at the moment: kurtgeiger.com, the flagship Kurt Geiger store for all our brands, sureholics.com, a brand outlet site, and 9west.co.uk, which is a site purely for the 9West brand in the UK. And all of these sites are taking around 500,000 page views a day, and taking quite major traffic. Our main interest in Amazon is for the front-end systems, which are the Magento installations that Ryan mentioned earlier. We host these on straight EC2 instances within AWS. We also use it for administration systems. We've got various back-end tasks that need to scale on demand through the night. We use it for testing. AWS is very adaptable. We can start up whole networks and systems on the fly, so it's suitable for trying out load testing of new products, and equally at the bottom there, research and development as well. Just basically a sandpit environment. It's hourly billing, so very convenient for us to just spin that up, try things out, and take it apart. So our main challenges, particularly with kurtgeiger.com, given that takes most of the traffic and has most of the product changes to it, it's a very rapidly changing business need. We've tried various other hosting providers that require long-term commitment, and AWS suits us here because we have a very fast-paced business. It's very difficult for us to predict what systems requirement we would need in a year or two. AWS, as I've mentioned before, is our hourly billing, so we can start at that smaller scale if we really need to, although the business doesn't quite change hourly, but that's suited to us. And then we have very heavy marketing activity on the site, which draws great reaction to the usage. So if we send out emails during the day, we tend to see a massive increase in traffic in the few hours after that email is sent. So we need to be able to scale up very quickly. Why Amazon? As I've mentioned before, it's a unique model amongst other cloud providers that we've tried. There are many providers out there offering a variety of different services. Amazon just happens to be very well suited to our needs. It's not just servers that we're spinning up. We're able to scale individual servers. We're able to add complete networks of servers. They can be private or public networks, and all of that is delivered on a self-service basis as well. There's no need for us to submit tickets or make calls. We manage the whole suite of servers ourselves, 24 hours a day. They do offer support, which we use from time to time, but we find most things we can just crack on and get that all done for ourselves. And as far as we are at the moment, we have got a very good relationship with Amazon. There's no hitches. We plan to use them in future, and this will be for larger capacity architectures as the sites are taking more traffic. As we add more sites to our portfolio, we can simply scale up our usage in Amazon. We also hope to take advantage of their API-based approach to starting systems. So commonly we would use their web interface to just manage the systems because that's user-friendly, but we are also able to script perhaps whole systems to pop up on demand. And another feature that we're thinking about taking advantage of is the reserved instances. As our architecture becomes more stable, we can reserve usage when we know that we'll need that over time for further cost savings. So just kind of recap on the benefits that we're getting. Certainly the hourly billing is sets them apart from the other providers that we've used in comparison with a physical tin environment, which we would have used in the past. We would perhaps have had 48 months, 24-month commitments to real kit on real premises, and that just, as I mentioned before, doesn't suit our model. There's large capacity. I can't remember a time that we've scaled up and wondered whether or not the capacity would be there. It just is. There are kind of manual limits on the account, but they're just expanded and we just keep growing and growing. So again, that really suits our need to scale on demand. And then Amazon is a trusted provider of ours. We have a good experience with the platform. It's very reliable, it's very robust. In general, unfortunately, if it's a problem, it's usually with our website software. We have they've worked hard basically to build a good relationship with us, and we look forward to carrying on that in the future. So that is essentially it. I'll hand back to Ryan now. Thank you.
Thanks, Adam. So that gives you a bit of a flavour, rather than me talking about the benefits and how someone's use it, but someone at the heart of the retail organisation. Now, when I said I was coming here to visit Kurt Geiger to give this webinar this morning, my girlfriend was ecstatic that I was going to come away with some shoes, but she might be disappointed, I think. You can get started with Amazon.com for free. So if you don't know this, you can sign up today. You can use your existing Amazon.com account that you might use to buy books and have a play under what we call the free tier. So you can run compute instances, databases, have a play with the storage and get a feel for the resources that are there that might benefit your organisation at zero cost. So do try it. Sign up at aws.amazon.com/free. And if you want to speak to someone specifically about any use case, you can also reach out to us on that website using the Contact Us form. And one of our team will come back to you and have a human conversation about your use case and how Amazon may or may not work for you. So do give that a try too.